Hello and welcome back to another gas walkthrough. Today we're looking at Monkey Moon by Philip Newman. Hello, it's one of our says here at Gas HQ. So my name is Bill Murphy. It's my pleasure and honor to solve this one for you today. Um, if you've never seen this before, hello, blessed be the algorithm that brought you here. If genuinely approachable Sudoku is your thing, then welcome. It's a pleasure to have you. We make our own Sudoku puzzles for you, Solver, at home, reading this. Um, and we post them every day. You can do this one too. It's in the description down below. You will also find hat times. Hat times are our indicator of how fast or how doing a puzzle. 2 hats is for a very fast time. 1 hat is for a pretty fast time. Everyone gets a consolation dinosaur because we love you all equally. That's basically it. I hope you're doing well. I'm tagging in today. Well, I don't normally do the Philip puzzles, but you know how it is. Philip had to go to watch people play Rocket League, I believe. So I get to solve one of his today, and I know this one's a banger. So this is Monkey Moon. So normal Sudoku rules apply. So each box, each row, each column must contain the digits 1 to 9 once each. Now, these cages and lines are anti-Renban. So we've done Renban a bunch of times on the channel before, but these are anti-Renban. So digits along lines / in cages cannot repeat. No 2 digits on a line can be consecutive. So this cage / line up here, because this has a 6, it cannot have a 5 or a 7 on it, because they're both consecutive 6. Doesn't matter where it goes. But say I put a 4 there, this can no longer be 3 because it'd be consecutive to a 4, 5 because it'd be consecutive to both, or 7. Right? That's what we mean by anti-Renban. So that's it. That's all you need to know to solve the puzzle. So I'm gonna get into it. Let's get going. So the secret to this puzzle to get going is that this is a 5-cell cage. Now, the only way you can have 5 cells have no consecutive digits is if they're all 4. And that applies for every single every single cell in direction. So what that means is, well, first I can make that a 4-8, this is a 2-6, but then we can fill these in because this has to be a 3, because 3 can't go into any of those cells. This has to be a 5, this has to be a 7, and this has to be. Now, I've got to do a little bit of a 5, 9, 5, 7, 7, 9. What's this? 1, 7, 9, so that's 7, 9, that's 1, 7, this is 1 and 9. This is 1, 3, 9, so that's a 1, 9, 3, 1, 3, and 3, 9. And this is 3, 5, 9, so that's 3 and 9, 3 and 5, and 5 and 9. So that's a good start. Now, if I was parity shading this, I'd know that every single one of the digits is also even. So let's go ahead and do that. So I'm going to clean these up. It's going to take me a second. Patient. Okay. I can't put a 6 here. Means I have to put a 6 here. Means I can't put 6 in any of these cells. So I'll take the 6 out of that. I'm going to take the 2 out of all of those. This is a 4-8 pair. We can do 8 and a 4, meaning this is a 6. Now, 2 and 6 over here mean that that's a 4-8 pair. This is also, but this 8 over here takes the 8 out of this cage, making that a 4 and an 8. 2 and 6 make that a 4 and an 8, and this is a 2. That's not anything. Please ignore that happened. It's just I'm not being melodramatic at all. Now, that resolves all of that. And now we can even push this a little harder. We know that these 4 digits have to be 1, 3, 7, and 9. Oh, are those the cells I want to push? Nah, I'm going over here. Let's go over here. Now, where does 5 go in this row? So, because I know 5 can't go in any of these cells, so 5 has to go here. But if 5 goes in this cell, I have a 3, 5, 9 triple. So because I can't put 5 in that cell or that cell, the only way I can put 5 in any of these is if I put 5 here. So that's 5, 3, and 9. If you spotted the same thing over here, that the only place you could put a 1 is this cell, that also excellent logic. 2, 6, 1. Okay. What's this cell? Does that work? No. I'm trying to figure out where I want to look next. Let's look over here. Not where I want to look next. I know a 4 must go in there. Maybe let's do that instead. So I need to put. So I need to put a 2 and an 8 down here. There. So I need to place a 1. So I know that I've got a 5, 7, 9 triple here, and I've got a 6 in here. That means I've got 4 digits left to place in the box. Now I got to put a 2 and an 8 down here, and I've got to put a 4 in here. We know that because we got 2 and an 8 there. So the only digits not accounted for are 1 and 3. Now, the real trick here is that where does 3 go? Because if I put 3 here, then it doesn't matter whether it's 3, 4 or 4, 3. Both of those are consecutive to each other. So that tells us everything that we need to know about these boxes. That's 2, 3, and 8. Now, we have the 3 and 2 over here, which is 8. And because we have a 4 over here, can't place a 3 here. So that's 2, that's 3. 4 and 8, 1, 9, 3. And the whole thing kind of unwinds, almost. Now, I will give you the heads up. When I was testing this, I do believe I said that this is probably on the trickier end of what we allow ourselves to do at Gas HQ. Pardon me, I am working from today because I don't want to get everyone at work sick. Or sicker than they are. So if I'm coughing, please forgive me. But this puzzle is a bit trickier. It is reflected in the hat times for today. So if you found a different way through, or a better way through, or a neater way through, I love that for you. All right, this is 1, 5, 7, or 9. So what's this cell? Can't be 5 because it'd be next to a 4, and it can't be 7 or 9 because that would be next to an 8. So this has to just be 1. Now that we know that that's 1, can this be 2? No, it has to be. And I'm almost certain the same logic. Yeah, that's 3, 5. That's 1, 3, 5, and 9. Yes, it does. Because we got a 4 here, this cell can't be 3 or 5. Because we have an 8 here, this can't be 9, so that's a 1. We'll take a 5 out of there. Now, 3, 7, and 9 left to place over here. 3 would be next to a 2 and a 4, so we can't do that. 7 would be next to a 6. So that's 9, which means we can do the rest of that row, which is lovely. 7 over here, puts a 7 up here. 5, 7, and 9. 6 single-handedly rules out the 5 and the 7 here, making that a 9. 5, 9, 7. This is a 5 and a 9. 5 and 3. Right, we are nearly done. Okay. 1 and 3. 3 and 6. 9. Oh, that's not a 9. What is that? That's a 5 and a 2. Whew. You tell how badly I really just want to crawl back into bed and go have another nap. 2, 6, and 1 and 2. Yeah, we can do that. 1 and 2. That's been Monkey Moon by Philip Newman. My name's still Bill Murphy. Wherever you are in the world, I hope one, you have a fantastic rest of your day, and two, you're doing a little bit better than I am right now. But I will catch you next time. Cheers.